And it's always good to have a Dilbert take on big data. And this one came out, this one I found, and they're just absolutely perfect because it's a good cynical look at all these new buzzwords you hear about big data. And it's dead on. And we will explain what in-memory computing means. Why the buzz? Just to give you a little background, before I came to SUSE as a sales engineer, and I live in Pleasanton, I'm a California citizen, I'm really pleased to be here. This is the first time SUSE as a company, as an enterprise Linux company, has ever talked about big data. It's very new. It's so new that the brochure that we talk about big data was just printed 20 minutes ago. So, really, 20 minutes ago. It's hot off the press. Before that, I worked as an engineer for Cloudera, one of the big Hadoop, commercial Hadoop custom solutions companies. And inside of SUSE, you know, when I got to SUSE, I landed there about 6 months ago. You know, everybody was like, well, what are we going to do? What are we going to do? What are we going to do? You know, how to address it? Our customers are asking questions. And so basically, since I've come there, I've been thinking and talking with customers about, you know, who are the ones doing things now? You know, what do they want to gain and things like that. So some of the insights that I've learned talking with customers and solutions providers and all that, all those folks, hopefully can give you a view, a high-level view of, you know, what you should be looking at, you know, the thoughts and thought processes going into doing that sort of thing. And, you know, it's easy if you're a technologist and being in technology to be a bit cynical about all these new buzzwords. You know, you've had client server years back and all these, you know, is it really the big deal? Is it really a big deal? And yes, it is. There's no question about it that the way that big data can transform the way we handle IT, the way that we communicate, it's definitely a transformative technology. And it's still early days. Most of that's been enabled by the drop in pricing of storage and networking. And, you know, nowadays, gigabit Ethernet is on pretty much everybody's desktop. I can remember putting in solutions for clients years back when gigabit Ethernet to your desktop was, oh my God, that's so expensive, you know, $900 a seat for something like that. Now it's common, even is on my smartphone. Just to give you some numbers, because the numbers are actually staggering. When we look at how much data we collect, and most of it's driven by the internet, look at the difference in pricing for storage and networking. It's very common now inside server rooms to see 10 gigabit interconnects inside of data centers, whereas even 5-10 years ago, that kind of speed was the realm of high-performance computing and expensive research labs. You know, what's big data? It's really a bunch of technologies all about handling all the kinds of data that we don't keep in traditional relational databases. And you have to think about big data in terms of differentiating, you know, what kind of data you have, what kind of data can you not access or use in a meaningful way. And also, when you think about big data and how you're going to use it for an application or for some sort of integration in your current workflows, you need to think a lot about what kind of data you have. They all have different types and different tools. Not every tool is not a one-size-all-fit solution. And you really do need to find the right data, big data solution for the application you're using. And always when you get into when you have in IT, you always need a jargon list because there's a lot of buzzwords and you hear these things floating around. And Hadoop is the open source big data machine. It originally came from Yahoo, and it was the basis of the original Yahoo search engine. And so what happened is Yahoo open sourced Hadoop, and in that case, all of a sudden people and, you know, data scientists, people that are involved in research said, this is really interesting, we can do some stuff with this. So when you think about Hadoop, the core parts of Hadoop are two parts. It's basically a file system, a distributed, scalable, fault-tolerant file system, and Apache Hadoop is a whole ecosystem of different open source software technologies. Some of them you could say are competing, some of them are complementary, but there's a lot of action in that space, and it's very interesting seeing that even places like the AMP Lab now has a stack called Spark, which looks very, very promising. And what's interesting also is that these kinds of developments coming out of a lab into commercial production, that cycle has been really shortened by the fact that the Apache Hadoop ecosystem is actually alive and kicking. It's very vibrant right now. And you hear new SQL, no SQL, and basically it's just a different way of storing data, and mostly in memory. You'll see a lot of different solutions that say, well, it's no SQL, and these are the advantages, and speed, and all that sort of thing. It is useful in some situations, and some situations it's really not a path you want to follow. And when we talk about data, we talk about data as a temperature. You know, cold data is your archive stuff. Live data is stuff basically in memory or very close to the compute centers of your big data tools, and dead data is archive data. Why do we talk about dead data? Because what these big data tools give you is the possibility to use what we would think of as archived and dead data to actually gain insights into it. And the other term you'll hear a lot about is ACID compliancy, and that's basically a term for relational databases, whether it's ACID compliant or not. Most of the no SQL solutions are not ACID compliant, and they sometimes, and many times, they don't need to be. Any questions? During the talk, if there's anything that's not clear, you know, raise a hand, yell, throw something, whatever, catch my attention. We talk, you hear a lot, when you talk about big data, you hear about the 3 Vs, the 4 Vs, and the 5 Vs. Certainly, big data, it's the volumes, the variety, it's things, the kind of variety of data that you can handle in big data solutions is everything from Twitter feeds to log feeds to geographic data, mapping, images, metadata from images. And when we talk about velocity, the speed that we're capturing at, which seems to be growing almost exponentially. And the value of it is, you know, what's the really valuable data in this big haystack of data, and what's really unimportant. The last one I always put is called veracity, and it's an important part of when you look at a big data solution is, do you trust your data? And is your data clean? Is it deduplicated? Does it have missing pieces? One of the things that a lot of people don't talk about, but I think it's very important, is to make sure that you actually can trust your data. Any questions? These are examples, certainly maybe not so relative to government, but these are what we see out in the field and what people are actually using, the types of big data that people are crunching. And it's interesting that the Hadron, the data sets that are coming out of that particle collider are so big that there's actually a farm in front of the data collection. There's so much data that they actually cannot store it all. They actually filter it with a huge stack of big data machines just to filter out the important bits, because if it's physically impossible to store all the data that comes out of those colliders. And certainly things like financial data, medical data, and there's a lot of interesting things being done around medical data, the ability to coalesce geographical data with health data, yielding things like being able to track outbreaks of flu and other things like that. And certainly we know a lot about web and social media, telecommunications. That's a big thing. Almost every telecom company I know of either has a big data program in place, or they're in the state of doing that now. And web server access logs using big data can give you some trends and analysis and help guide your search engine optimization and sales data of all types. Why you want big data? One thing is it gives you transparency into what's going on. Sometimes the most important thing is, you know, asking the right question, and that's the realm of what we'll talk about as a data scientist. Now, the state and local governments being constrained by budget, thing like that. If you want your kid to make sure in the next 10 years that your kid's got a good paying job, you send them to school, teach them math, some IT, computer sciences, and some business. And those are the 3 competencies that we call, that enable somebody to be called a data scientist. And in fact, the people who have started many of these big data companies, like Jeff Hammerbacher, who started Cloudera, He's an honors graduate mathematician from Harvard, just to give you an idea of the skill set that you need to have. And now, here, when we look at the government side of it, getting that kind of talent is near impossible because the salaries are astronomical, and most of the really, really sharp guys, they're getting lured into companies with big stock options and things like that. The main use cases is decision testing. There's a lot of different ways you can use decision testing. You know, what happened, will happen, individualization in real time. That's one of the things I love. One of my favorite apps is, you know, Google Maps. I think it's a phenomenal application of big data. And the way that it tailors what you're looking for almost instantaneously is fantastic. And you can use it for intelligent process control, automation. When it comes to automation, and an example of that would be credit card companies using big data solutions for fraud detection. And how do they do that? And one of the things that big data tools are really effective at is detecting what I call anomalies. For example, okay, you buy something online at Amazon for $100, and all of a sudden there's 2 transactions that come over your account for 50 cents, one in Estonia and one in some other country. Those are what we call it's an outlier. And that's one of the things that big data can do in real time to detect those. Like, that's not right. Why would somebody spend 50 cents on their Amex Platinum and boom, and stop the transaction? And in fact, that's one of the ways that a lot of the financial scammers actually pull money out of people's accounts unknowns. There's lots of millions and millions of small transactions. And so the big credit card companies are using big data to not only just for data mining, but also to do real-time fraud detection. And of course, it gives you new ways of doing business. And when we say data-driven business models, when you think about it, Facebook, Google, Yahoo, and all of those folks that are doing that are internet companies, they're basically data companies, and their motto basically is we throw nothing away. And that's part of the big data story, is that, as I said before, dead data is archived data. And as you can see, it's and other companies are working on enabling those same sorts of things, whether it's through shopping on on the internet, changing pricing depending on location, geolocation, and all these sorts of things. Any questions? How to distinguish between several kinds of big data? Certainly the amount and the size, whether it's structured and unstructured. One of the great things about big data solutions is the kinds of things that you can shovel into a big data system. It's really, I always tell people, the best physical representation is think of your relational databases, your Oracles and your DB2s and Access and all those types of structured databases. Basically, you've got to have the data lined up before you can put it into those nice slots. Big data is a big funnel. You just dump all that stuff in. Just dump it all in. And the file system, the basic file system called HDFS, and there's some competing alternatives to that, it's extremely good at handling all that sort of thing. So you can really make a blender full of data types. Okay, for example, I'm a state agency. I can dump all my geo info from mapping. I can dump in census data. I can dump in queries from my websites. I can dump in revenue tables from like revenue for taxes, for population density, all those sorts of things. You can dump all that kind of stuff in and then think, okay, now I have all these things in the same bucket. What do I want to look for? How can I use this to come up with new ways of applications to serve not only the public, but also to make better decisions internally. Think about, for example, one of the things that, you probably all heard of William Bratton, the former Boston and New York City police commissioner who revolutionized New York City policing with all that sort of thing. A lot of that was done through a big data solution. Basically what they did was they took a chunk of historical data and geographic information, and they dumped it in to a big data stream. And what they then saw was physically on a nice dashboard where crimes were committed. So then from that, they used that to decide where to deploy all the police officers. And so when we talk about the policing on the street, putting guys, taking the police officers out of the cruisers, putting them on the street. They were posted in those places which were considered hotspots for crime. And that's just one government application of a big data solution. You have to think, how complex is your data model? And one of the things about big data is that enables some rather complex data modeling. And so, as I said, you take this big funnel full of stuff, blend it all together, and it allows you to look at it on a lot of different ways. You need full data integrity in the sense that a relational database should, in theory, guarantee it. It's not always required to actually get useful insights out of a big data solution. Usage patterns will guide you in.
What's an example of not needing the data integrity? How would you get something useful out if your data didn't have integrity?
Well, for example, geolocation data would be a good example. It doesn't have, it may be imprecise instead of being, okay, it's exactly on this block. If it's within say a 1 square mile region. So that's the difference in, integrity or accuracy. That's kind of, those are complementary. So when you say full integrity, how accurate do you want to drill down your data?
How much of a margin of error can you tolerate to make the decision that you want to make?
That's a question for a mathematician.
That's my response to it. But
yeah, that's
sometimes very precise data is needed. Other times it's not so important.
Exactly, and it also relates to you have a quantity precision relation as well. You've got lots and lots of data, but it's not terribly precise. Perhaps over time you can use some modeling to actually generate a synthesized set of data which is actually more accurate than what you originally had.
What if some of the data is just plain out false?
That's where I went, I said in a previous, the idea of veracity.
Okay.
That's one thing that's a very important consideration in importing big dumps of data into one of these systems. And what's your usage case? Do you need real-time performance? And mind you, when you look at it at a real-time performance case, I wanted to give you folks an educational talk, not a big sales pitch, but just to give you an idea, what I consider right now the highest performance big data solution is SAP HANA. It's an appliance that I'm proud to say runs only on SLES, and that's not the sales pitch, but the point is HANA is extremely fast in-memory database, and its transactional capacity is amazing. But for that kind of real-time data analysis, you're paying, you're talking a minimum of an $80,000 server. That's a small one for SAP HANA. So the faster and more real-time you want, your price goes up, basically. And it relates also to clouds, and I'll talk about that in a little bit and later. One of the things that really ties in with big data and clouds, and why it's a natural for a cloud environment, is that you may get your batches of data in a fixed time frame, whether it's daily or it's nightly or it's weekly or monthly or quarterly. And having a big data solution, doesn't require you to have a whole stack of machines set aside for a big data cluster running 7/24, and that's where clouds really work nicely. Now, to give you an idea, the difference between Hadoop, and I use Hadoop in this sense generically, the open source big data solutions. The big difference is, as I said, you take all this data in a big funnel, just dump it in. You don't have to predefine your schemas. It loads very fast. The data structures are simple and it's agile. Whereas a traditional relational database, your Oracles, your DB2s, etc., you've got to have your schema defined in advance. Your data does get transformed, because we always talk about ETL, extract, transform, and loading. It's optimized for fast reading because of indexing, inbuilt indexing and joining, and you've got standards and governance. But the real innovation about big data is the capability to explore your original unstructured, unmodified, broad data. That's the real innovation at the bottom line. Any questions?
With
ETL process to load the data, dump the data into a funnel, or are you actually using just pointers to in-memory analytics?
You can do both. You can do both. In fact, one of the things that's interesting that that HANA SAP is doing is, you know, when you go talk to big data vendors, you say, okay, SAP HANA is this. It's a it's this big in-memory analytics tool, which is very good, very fast. And IBM has a competing product as well. The flip side is you can do the same side of ETL stuff inside of the NoSQL Hadoop scenario. And also, what's really cool is that the bigger high-performance solutions like HANA and IBM's big thinking analytics tools is that they actually are making connectors to allow Hadoop to sit alongside that SAP HANA in-memory database. And you'll see other solutions like that. So it's not an either-or kind of solution. You actually now have the opportunities to put both together and work with them side by side. And in fact, at Cloudera, one of the things that Cloudera has done in commercializing Hadoop is they work with a whole bunch of database vendors and storage vendors to create connectors to enable people to take Hadoop as a storage and pull traditional data warehouse files, and they have a whole bunch of them, Netezza, NetApp, there's like 7 or 8 of them. So the idea that it's an either-or question, not really applying. Come on. This works better. So, what's your when to choose one or the other? Hadoop scalability is pretty much unmatched. Yahoo has clusters up somewhere, if I remember right, somewhere over 40,000 nodes running Hadoop. I know that publicly people have scaled up Hadoop clusters inside of Amazon's EC2 of approximately 3,000 nodes. Whether your data is highly structured or unstructured, and you have a complex data process that you want to actually combine sources from many different sources distilled into a simple a simpler app or simpler output of information.
What defines needing a node or multiple nodes? Just trying to get an idea of what that number means.
Well, from a memory standpoint, to give you an idea, if you want to have a prototype to experiment, what I would do is get a freely downloadable copy or distribution from one of the commercial vendors. Cloudera has a freely distributable, and they have a manager tool which is quite nice, and Hortonworks has one as well. And start up a node on, you can even do it on one machine, a good sized server with 32 gigs of RAM, and one controller node that launches and runs all the management consoles, and add 10 of them as worker, or we call data nodes, 2 gigs apiece. And the idea is you want to pair each CPU to a disk, because that's part of the way that MapReduce, the other part of Hadoop, works, is that you want to have your data close to your CPU computing. And the other part of it is that the HDFS is automatically going to replicate 2 copies of your data. So whatever your data is, your disk needs to be at least 2x your input data. And we always recommended, just from my recommendation is a minimum of 2 gigs per node. 4 gigs is ideal. You really don't need that much more, because it's more architecturally, the challenge of big data is I/O, is disk and networking. And you definitely do not want to run it on anything less than a gigabit interconnect.
So what you're doing is you're threading across multiple nodes in order to reduce the I/O.
Exactly. That's part, we call it MapReduce, but actually that's the mapping and the reduction. We actually break the jobs down into small, discrete chunks, send it out to each node. They do its data crunching, then they send it back. Then they send the data back to the job tracker and the task tracker.
So when you say 3,000 nodes, for example,
that's a huge.
About a performance metric, not necessarily memory size that's being managed or anything like that.
Yes.
So you want to have that many users essentially that be able to be handled in parallel.
Yes, and the thing when I say it's scalable is that the scaling is near linear. So if you have 100 machines on your cluster, you add another 100, and you've just doubled your performance. You don't see a 1.5 times performance gain. You see close to an exact 2.0 times gain in performance. What are the strengths of Apache Hadoop? And this is I think of the big, large ecosystem of about 12 different projects inside of Apache. Its ability to digest huge volumes, and certainly we talked a lot about unstructured data. It's quite reliable. The Achilles heel of Hadoop is one part of it called the name node, but there's a lot of work ongoing to actually make that a lot more robust. The problem is if you lose a name node, you basically have to restart your batch job. So if you've got a job that's running, say 6 hours, and halfway through the name node dies because a memory chip went kaput, you've got to restart. That's one of the Achilles heels of Hadoop. It's certainly hugely scalable, as I said before. And the cost, it's all open source. Basically, all of the commercial providers, basically they smooth off all off the rough edges, package it, integrate it. It's all Apache or GPL license, so it's freely downloadable. And you can pick and choose from a menu of options for support and consulting and training and things like that. I'm always a big fan of open source software in general. That's how I started in Linux, was starting a little project just for fun, just to learn. There's no hardware lock-in, which is another plus about Hadoop. And it's a batch process type of tool. It's very much, you launch jobs just in the same sense that 30 years ago when you were on a mainframe, you'd launch jobs and you'd have a time-sharing system. And that's why it's such a natural application to reside in a cloud environment. And in fact, doing testing, just to give you an example, when we were doing QA and regression testing at Cloudera, we almost never ran those tests on bare metal. They were almost always on some sort of virtualized environment, basically a private cloud that we had built out. And we built out 1,000 node clusters, and it was all completely virtualized. Oh, come on. What are the weaknesses? And I see it as it's really not efficient on small scale. You really need a cluster of about 50 machines to really start talking about being able to do something realistic, so that your data sets are large enough to give you something meaningful. Real time is challenging. There's a lot of companies now that are working on it, so I put work in progress. Real time inside of Hadoop is imperfectly solved, I would say, at the moment. Maybe 2 years down the road, you're going to see a really robust solution that will be equally performant to, say, the SAP HANA appliance or IBM's Think Big analytics tools. It's really challenging to really know how to get up and get real data out of a Hadoop cluster. You still need what I would say that the immediate skill set you need is somebody that's really skilled with SQL. Because a lot of the tools that work with Hadoop and Hadoop clusters are some sort of variants of SQL. And they have all these crazy names like Pig and Scoop and Squirrel and Hive and HBase, and basically, and Pig comes from Pig Latin, because basically it's a scripting language that you use to run on your clusters, and it has it's basically like Pig Latin. It's basically a subset of structured query language. So that's why I said it needs skilled engineers. You need engineers that are capable of standing up a reasonably sized, robust Linux cluster, because most everything in the Hadoop world runs on Linux. Yes, Microsoft says we're going to have Hadoop, but it's far from being a production-ready piece as far as I know. So therefore, you need skilled Linux administrators, and those are the good ones. They don't fall out of trees, especially if you're in the Silicon Valley area. If you're a good Linux engineer, you basically have a job for life, because if you don't like where you work now, you can find one tomorrow. Certainly doesn't have the maturity of SQL. SQL has a 30 year some head start in terms of being a defined standard. And the other part that's tricky, and this relates to government specifically, is what we call weakly defined user roles. Yes, you can enable what we call secure Hadoop. And what that means is, for example, you can use LDAP, or you can even use Active Directory to control your access to your Hadoop clusters and the data, and especially where government has lots of sensitive data. But those are, I would say, imperfectly defined. They're a bit, it's an all or nothing kind of thing. There is a company that's coming up with a similar, that's a spin-off of actually an NSA project out in Boston called Squirrel. Now, squirrel, like a thing that eats nuts, but actually what it is, it's a way of storing that big data stuff in a very granular access model. And that's why the NSA developed it, because they found that they could not use a traditional Hadoop because of the kinds of data that they stored, and having, they needed very granular access and auditing to know who looked at this file when, et cetera, et cetera. Sure.
So you said one of the weaknesses is real-time data, right? So we talked about velocity, big data having actually advantages of having big data is velocity. So it seems like when you say Hadoop is not going to be handling, or it won't handle real-time data.
The solutions are going to come from a couple of different directions. Number one, yeah, you've got the high velocity streaming into your Hadoop file store, but you still got to map it and reduce it, and it's batch oriented, so it doesn't have quite the interactivity of some of the other big data solutions. That's why I say that it's challenging. The big data, the other part of that solution is that in the Apache project, people are working on having a solution to enable in-memory to work better, and to set prioritizing, which chunks of data are more important than others, things like that. If you're looking for a result in 2 columns, I want column A to come out before I see column B. Those kinds of things are being worked on, so it's work in progress. Big data challenges. I'm not a government expert, and I've never really worked inside of government IT, but as an outsider, I would imagine that these are some of the challenges that you're going to face. It's not that they can't be overcome, but they are challenges that you need to be aware of. I've been certainly made aware that, because of the nature of government, by its very design, a lot of data and data workflows are siloed. I mean, why would somebody in the Department of Health need my tax records? And for valid reasons. So the data is siloed, the workflows are siloed, and we certainly have sensitive data concerns. Regulatory blockages that may disable you from being able to share data amongst departments or across towns or across regions. Budget constraints. We all know that the state and local governments have a lot of budget constraints owing to the economy and reduced revenues in a lot of different areas, and the planning lead times. And one of the great things about the whole cloud movement is that it's going to allow you to reduce those planning lead times. I think that's one of the really great things about the whole cloud direction the state's taking. And what I call clouds, when we really talk about clouds, what I'm thinking is compute on demand. That's the real advantage. So that you don't have, as an agency, you don't have to say, okay, I got to write an RFP for this big stack of servers and this networking gear and this services to implement it and support and all that sort of thing. If it's in the state data center and you've got a cloud that you can get access to, boom, that's just short-circuited. How many months? Lots. And budget, and budget costing as well. The opportunities. As I said before, the compute-on-demand model fits really, really well with big data. And in reality, most big data solutions, if not all, if they're not there yet, they will be cloud-enabled. And in fact, Hadoop, part of the Hadoop ecosystem, one component is called WIR. And basically, WIR's job is to enable you to spool up a cluster inside of clouds, and it's already got predefined templates so that, okay, I want to put my cloud on EC2, or I want to put it on Rackspace, or I want to put it on some other data center's platform. And I would imagine in our SUSE enterprise cloud, very soon you'll see one for that as well, so that, okay, I take this cluster that I fired up in EC2, and here's my director, here's my director or my management machine, give it the IPs, push a button, and it launches your whole Hadoop cluster live inside of a cloud. And because most of the big data solutions are very much batch oriented, they really work well in a shared environment. I know even in testing in Cloudera, we would take up clusters and up and down all the time. We would test on various operating systems, we'd test various components, different versions, all that sort of thing. So I've seen how that works in a shared environment. The other great thing is open source. There's no vendor lock-in. Nobody's trapping your data inside of a system that costs lots of money and consulting fees and et cetera, to migrate from one big data solution to another. It's basically what you run on top of your big data file system and your collected big data that really is the differentiator. And the thing I think that's really cool is, it gives you scope to think about new and different ways to actually find new ways of processing and relating to the citizen, to our state and local citizens. Wouldn't it be lovely to be able to go onto say a town website and say, oh, all these parking spots are open, and know that? And we talk about the smart cities. Big data gives you those opportunities to actually imagine and actually implement those kinds of things. That once implemented, it doesn't require any extra staff. We don't have to hire people and all that sort of thing. The other thing that I think is really cool, even with the caveat that we know we have some regulatory issues in sharing data, this goes back to one of the things before, the idea of veracity, is that imagine if we were able to combine things like, say, tax data and land planning and some other sorts of data, and say, for example, Medicaid, Medicare payments, and actually use those for detecting those outliers for detecting fraud. Imagine and those come from different departments, and so mixing and matching data from different departments, which are currently siloed, give you the opportunity to do new and different kinds of things very efficiently. And the most important thing is it allows you as agency IT managers and architects to concentrate on your core competencies and not have to worry about running a data center. And that's where I think the cloud solution that the state is moving forward towards is really, that's the big win for me. And evaluation thoughts, when you're looking at your big data solutions, I don't want to run out of time, the question is, we've seen a lot of technology. If it's easy to cast a jaundiced eye and say, is this some new trendy buzzword? Is it really significant or not? Is big data solution search for a problem? Absolutely not. There's too many concrete cases where we've seen that big data solutions drive really innovative solutions that provide better services for less cost and more customer satisfaction. As I said before, you need to evaluate the need-cost relationship for real-time data versus near real-time or batch-oriented. Do we have the right questions to ask? And when I say that, do we have the right questions to ask? Not everybody needs a big data solution. When you come to it and say, oh, well, I want to do some sort of this data analysis, maybe your existing tools work well and they just haven't been used in a way that will drive you the data results you want. And how can our big data workflows be integrated with our existing infrastructure and software? Very important question. What other agencies might have useful data? When I gave some examples of how integrating data from various agencies together might provide for some really interesting analytics and insights. The whole point of the big data thing, the whole point of it all is to get data to turn into actionable, useful information. That's the whole point of it. And in all of this evaluation, you don't see that coming out of a big data solution, then don't do it. And pilot. What we find, I can say from the commercial side, from the enterprise side, the companies that I saw have the most successful results from working with big data were the ones that invested heavily in running pilots. And they would actually run 2 or 3 different pilots in some cases, using different data sets to come up with a solution that when they put into production actually really derived the information they were looking for and was satisfactory and cost effective.
You talked about other agencies that might have big data. As a seller of big data solutions.
We don't sell big data ourselves. I have to say that.
Services, I guess. Is that what it is?
Our interest as an enterprise Linux company is basically to help customers find a partner that will give them the results that they want. And we have several partners that we work with that are big data providers. But that's basically how we approach it. We want to be able to have a conversation with our customers in a meaningful way about big data and say, okay, these are the providers we know of that work with our existing customers, good, reference stories, and have done good things. That's kind of been our approach at the moment. We don't actually sell a turnkey big data solution, which is.
I guess I was wondering if there was some sort of emerging service that pairs big data owners together in order to sort of find that cross-reference data.
That's an interesting question. No, not seen that. That's a very interesting question. No, well, there are commercial data brokers, and maybe you can buy stuff from 2 different, 3 different commercial data brokers and mix and match it in-house. I don't know.
I never even knew that. I knew that Google collects massive data and they use it, but we suspect that they sell it, but we don't know how they sell it. So how do we get a hold of it?
Well,
that's not a question for you. I just wondered if there was sort of a middle layer of services that sort of do that. I didn't know there was that.
Yeah, there are things called data brokers, and mostly corporations use them for marketing and targeting and some fraud detection, things like that. Even the credit agencies, they're data brokers. They'll sell their data from your credit reports to credit card companies, and the credit card companies will take that data, look at it, and say, oh, I think I'll propose a $5,000 card to somebody and a $2,000 card based on certain criteria. There's a question in the back.
So one of the things you mentioned earlier is that some companies have actually done several case studies or studies that have.
Let me re-say that so I can.
So I'm sorry, you mentioned that some companies usually have 2 or 3 investments in the area of testing big data.
Yeah.
What are some of the learnings that didn't work out so well, but we could learn from?
Good question. Good question, and that's something I can really give you a deep answer on. But if you give me a card, I'm going to ping a couple of the system architects and ask them exactly what they did. And one of them is a big telecoms company that I know we worked with for a long, long time in developing a big data solution. But they did a lot of piloting, and I wonder it's a really good question. What was the differentiators? What do they find in their first, second go-arounds? I also know that in the process of doing that, they actually tested different tools. That was one of the other things. They took the same structure, the same bucket of data, and would use different tools in the Hadoop stack and others outside of Hadoop to do their analysis and to test which one drove the best results.
I'll touch base with you after.
Sure. And when I put my slides up, you'll see a bunch of resources. Yeah, they're listed as this on some commercial sites, but they're all about learning a bit more deeply about Hadoop and big data and things like that. And if you really want to have a bit of a dive technically inside of the whole big data thing, that top one, the bigdatauniversity.com, you actually have some tutorials, and it's like a school. And it'll walk you through how Hadoop works and things like that. It's actually sponsored by IBM, disclaimer, but it's actually fairly vendor neutral. And it actually focuses a lot on Apache. And all of these are listed. The developer Yahoo tutorials is really good because Yahoo doesn't sell Hadoop, so their tutorials based on the core Apache uncommercialized. And questions? Any other questions, comments? The question I always, oh, go ahead.
I wondered if people will ultimately could use this to kind of do a query, ask a question, and maybe in maintaining the confidentiality of the data behind the answer, they never really even know what data produced the result. Like the crimes in New York answers, you'll get to know, you'll see how many there were, and that's it. That's all you needed to know. So you didn't need to know who the criminals were, and so you're not invading privacy, but you can still get your answer. Is that?
Yes, that's very much possible. We call it data anonymizing. So it just that's the technique. It's called data anonymizing. It's imperfect, as we find. AOL's had some accidents where they sent folks some thought to be anonymous data, and it turned out it actually was very capable of identifying people. Question for you, because this is the first time I've ever given a big data talk. Was this the kind of talk that was meaningful for you, and did you learn things? And what were the things that you would like to hear about that maybe perhaps I didn't cover? Ah, yes, sorry. Yep. That's just a bad habit, forgetfulness.
Maybe a couple real life use cases. You know, maybe a slide or two on
real life use
data. What was the result? That type of thing.
Sure. Really. Yep. Because
a little bit more specifics about the weaknesses of big data in comparison to RDBMSs or different kinds of queries. There must be some kind of use case where people rely on a lot sorting.
I didn't want to go too deep in the tech because I knew some of the, but that's a very good point, and I appreciate that. I didn't want to go too deep in the tech because I wanted to give the people a big picture. That was my overall aim.
For the purpose of stake, though, audit proofing and separation of duties and those kind of things, if you're saying that there's weaknesses and it's a work in progress, maybe just one layer lower than that.
Yep. The good thing is the solution's on the way. That's the really cool part. Any other questions?
Top notch.
Thank you.
Thank you.
Appreciate it.